Yeah, so basically this problem is saying that it's a simple number game, and basically they count up from 1, and when they get a multiple of 3, they say fizz. Okay, hold up. Okay, could you guys hear me? Or hold up, I don't know. It's being weird. Could you guys hear me? We good? Yes, no? Okay, okay, we're good. Okay. So, yeah, what? Oh, shoot, my bad. Let me make you a oh, hold up, let me see how could I do it from here though? Okay, let me go to the main room and then I'll make you uh co-host. So go to the main room. Okay. Okay, where are you, Jeffu? There you are. Okay. There you go. Okay, we're back. Okay, let me start sharing again, and we should be good. All right. So basically, Farmer John's cows. Okay, so you guys get the idea. This is how it looks. And essentially, now we're just doing a simpler game, right? We're basically only saying moo every single time. So the idea is to figure out the nth number that we say. So does anybody notice anything here? Like any ideas for how we could approach this kind of problem? Any ideas whatsoever? Hold up. Could you guys see my Photoshop? Okay, so basic. Yes, no, yes. Can you see my Photoshop? DP maybe. So in silver problems, you generally will not see DP problems. So we probably will not have to use DP. Wait. So could you guys see Photoshop? No, you guys can't. Okay, hold up. Share screen, desktop one. Okay, now could you see it? Okay. So basically, we have one. Why am I using pink? Pink is such a bad color. Okay. 1, 2, moo. That's not how you say moo. 4, moo, so on and so forth, right? And basically, the third number set is a 4, right? The second number set is a 2, and so on and so forth. Hold up, this is too big. So 1, 2, 3, moo, 4, moo, moo, 5, or sorry, 7. Okay, so let's say that we know that the number is 7. How do we find out which number set it is, right? Does anybody know, like, what the formula is? Like, if we're given 7, how do we know which number it is? It's a fourth number set, but how do we go from 7 to 4? Any ideas? Like, just using math, right? So if there's, like, 7 things said, but only four of them are numbers, how do we find out how many of them are numbers? Yeah, basically, you could count the number of moves, right? You basically take the number of total things said, which is 7, right? And you subtract the number of moves, which is just like the number of multiple of 3 and the number of multiple of 5, right? So you would do like 7 over 3 minus 7 over 5. Now, what happens if. Now, what's the problem with this? Like, what happens if we go all the way up to like 15, which would be a moo? And then we're trying to say 16, how many things? Yeah, exactly. We had to add in a 7 over 15, right? Because we overcount how many times, okay, so this subtracts all multiples of 3, right? So we subtract out, like, multiples of 15 as well. This one subtracts out multiples of 5, but we're also subtracting out multiples of 15 again. So we subtracted out multiples of 15 again twice, so we had to add it back in. Okay, so now this is basically our formula, right? We basically take, if we're given a number k, and we want to see which number it is, right? We basically just do, k minus k over 3 minus k over 5 plus k over 15. Okay, so we're not given k though. What are we given? We're given n, which is the number, which number set it is. So we're not trying to go from 7 to 4, we're trying to go from 4 to 7. So how could we invert this somehow? How could we solve it? Like, how could we find k from n instead of n from k? Any ideas? Come on. Does anybody know what strategy we could use? Okay, let me give you a hint, okay? As k increases, this function always increases, right? Like, every time you increase. Yeah, Victoria, exactly, right? Like, basically, whenever you see something like this where you have a function that increases whenever you increase k, right? It's always increasing. You can just binary search on the answer, right? Like, let's say that we put like let's say that n is like 4, right? And we put k is equal to like 15, right? So then this would be 15 minus 5 minus, or 15 is never said, whoops, 16, right? We would do 16 minus 16 over 3, which is 5, minus 16 over 5, which is 3, minus, or plus 15, so plus 1, right? And that would give us, what would this give us? I can't math. Okay, equal 9, right? So would we have to make our k go down or make it go up? Anybody? Up or down? Down, right? So literally just by looking at what this formula gives, this big K formula, what it gives, we could decide whether to go up or down. And this means that it's obviously a binary search problem, right? So essentially you would start like, let's see, what according to the problem, what are the numbers? So n is going to be less than 10 to the 6th. So essentially we could just assume the K goes from like 1 to 10 to the 9. That's just a good option, right? So this is our starting points, and then we look at the middle, right? If the middle gives the formula less greater than n, then we just move it over. And then if, then this is your left and right, you look in the middle now here. If that's too small, then you move it up to these two, and then you look in the middle, and so on and so forth. So do you guys get that solution, right? Basically, we just found a function, but we didn't know how to invert it, right? So, but we also knew that it always increases, so that's why you use binary search. So basically, if you have a function that you can't invert, binary search is always a good option. So any questions about this one? Anything? Yes, no, maybe so. Okay. So, does anybody have any like specific suggestions they want? Like, because I don't think Albert's here and he wanted curling, but I might go over it if nobody has any other suggestions. Any ideas? Anybody want to say something? Okay, nobody wants to see a specific USACO problem. This is so sad. Okay, well then, did someone say something? A random graph problem. Oh, perfect. Hey, perfect. We're doing, well, this is somewhat like a graph. It's more of a geometry problem, so why not? We could do a graph problem after. What's wrong with computational geometry, Preston? Come on, it's beautiful. Okay, so basically this problem just says there are particles, right? And they each have an x and a y, right? And you could only, and basically if they interact, then one of them gets deleted, okay? And essentially, they could only get deleted if one is to the top right of the other. So let's take the example, right? This, okay, hold on. Okay, so the test case basically has your coordinate axis, your 4 particles, right? And basically, this particle right here can delete this particle and this particle. This particle could delete this particle and this particle because it's to the top right, right? This particle could delete these 2 particles, and this particle can delete these 2 particles. So does anybody know what's the minimum number of things we could have left over after they delete each other? Does anybody have an idea how we could delete stuff so that we end up with a minimum amount? Any ideas? Okay, well, basically the answer is like you delete this guy, right? This guy gets deleted, this guy gets deleted, and then this guy gets deleted, right? And basically you're left over with 1. So essentially the idea behind this problem is that you could only delete stuff that's to your top right. So like the way you would approach this problem, whenever you're in a problem and you're trying to find out which things can interact with each other, you should always make a graph, right? So essentially if we have like points like this, right? Let's say like that, like that, like that, like that. Okay, so these 2 points will be connected, right? Because they could interact with each other. These points can all interact with each other, right? And basically, the cool thing about this problem is that you can notice that no matter how these things are connected to each other, there's a way to delete all of them except one, right? Because as long as there's still a connection left, we can still delete stuff, right? So essentially, we want to find out how many of these connected components there are. And there's a pretty cool way to do it. Basically, you look at the minimum y coordinate from the left, right? And basically so essentially the way I did it personally is like, you go here, right? And then you keep going, you start from the leftmost guy, and you keep going right. And basically, if this guy is above the line, then you add it into this guy's group. And then this guy is below the line, so you make its own group. I mean, sorry. This guy is below the line, so you make its own group. This guy is above this line, so you add it to this group. This guy is above this line, you add it to this group. And this is above this line, so you add it to this group. And hooray, you basically got all 2 groups. And now you know that your answer is going to be 2. Okay. So that's a pretty simple one, but Preston, you wanted a graph problem, an actual graph problem, so why don't we do it? We'll do a graph plus DP. How about that? Okay, what are we gonna, what's it called again? Mortal Kombat. Oh wait, what is the actual thing? Okay. Bro, it's a thing. Nice. USACO. Bro, what? Come on. Oh, there it is. Okay. Okay, so I don't know how many of you guys have done this problem yet, but basically it says that Bessie had like her favorite move sequence, right? Each letter is a move sequence, and basically now the game is updated, and she has to make it so that there's like streaks of 2. So you have to have AA. You can't have like, you can't switch it every one. It has to be like AACCC or like AAACC, but each streak has to be at least 2 long. Okay, so basically, this matrix right here gives you the gives you how long it takes her to change, and you want to find the sequence. You want to find the minimum days for her to make a new move that is valid, right? That has the streaks of 2. So essentially, the first problem they present is that like it might be better to go from like C to E and then E to D, right? But like why? But like it's better to do that than go directly from C to E. So does anybody know how to like find the shortest path for all these pairs of things? These are basically this is basically a graph, right? So it tells you how long it takes to transition each letter to a different letter. So, like, does anybody know an idea to find all the shortest paths between 2 points? Anyone know any algorithms that are good for this? Come on, Preston, you know this. Come on. You must know. Okay, fine, let's read the problem better, okay? So, basically, a game uses M buttons labeled with the first M lowercase letters, right? Each thing represents a button, right? And basically, your favorite combo of moves is this A, B, C, D, E that they give right here. And each one must contain a series of streaks, where a streak is basically the same button pressed K times in a row. So in this case, it's 2, right? You had to press AA twice, you had to press BB twice, so on and so forth. And she wants to modify her old combo. This is not valid, right? You don't have any streaks of 2. All of these are streaks of 1, so that's not going to work. And she wants to change it to the new set of rules. But it basically takes her AIJ for each change. So essentially, she has to be a little bit careful with which ones she changes, right? Because if she changes to an A to C, but that takes her entire lifetime, it's not good, right? So essentially, that is a thing. And this part is pretty important, right? There may be a path with changes that start in I and end in J that is better than directly switching, right? So essentially the idea is to find the minimum amount of days to make your things valid, okay? So just looking at this matrix, right? Just like thinking about this constraint that like there might be a better path that's not direct. Does anybody know how we could find all the best paths without like pretty quickly? Any ideas? All best paths, like all shortest path. Hooray, yes, we got it, finally. Floyd-Warshall, okay? So basically, Floyd-Warshall, does anybody know how it works? Like, what's the time complexity of Floyd-Warshall? Anybody? N cubed, yeah. So, basically, like, okay, so technically Floyd-Warshall is not the best way to find shortest paths, right? Like, literally, okay, let's say you run Dijkstra from every single point, right? That would still give you all shortest paths. What would the, yeah, no, I know, like, that's a thing, but like, what would the time complexity of that be? If you do n Dijkstras. Dijkstras is basically like n log n. So if you do n times, I mean, yeah, just say n squared log n because who cares about like being exact, but yeah, it's fine. So yeah, basically Dijkstra would technically be faster, but we're still gonna go with Floyd-Warshall. You want to know why? Why do you think we're still gonna do Floyd-Warshall? Why is it better to do Floyd-Warshall even though it's slower? There's a very good reason for it, which is actually kind of important in USACO. Does anybody know? The reason why we do Floyd-Warshall is because it's easier to implement, okay? And literally, like, m is only less than 26, so 26 cubed is nothing, so there's really no reason to try to do Dijkstras, right? Because Floyd-Warshall is already fast enough. So essentially, the way that Floyd-Warshall works is that you have a bunch of points, right? Like this, you go like that, you go like that, that, that. And let's say that this is like 1, 2, and there's like 4, and there's like, I don't know, let's say 2, well, let's say there's 8, and there's 4, 1. Okay, so essentially, right, like the idea is that the distance between this point and this point is actually 3, not 4, even though it's directly 4. So basically what Floyd-Warshall does is it basically goes through each point and it considers it as an elbow, right? So essentially, let's say we set this guy as the elbow, right? Then we look at this elbow. Is this better than directly? No, I mean, yeah, this is better than going directly, right? Because you can't even get there directly. So essentially you do, this is the best path if this is the elbow right here. So we change this to a 9, right? Okay, then we try this as an elbow, right? And then we basically say, what's the distance here? Is it better than 2? No, it's not better than 2 to go 4, 1, that's worse, so we don't change that. Okay, then that's the only other possible path. Oh, yeah, okay, also this one, right? But that's not better, so that's not good. Okay, then we move on to a new elbow, okay? So let's say this is the elbow. Then you go like this, is that better? Oh, 4 plus 1 is 5, which is less than this guy, so we just change this right here. So that would be 5, right? Okay, and then what's another elbow we haven't done yet? This one. Okay, so if we do this elbow, right, what's gonna change? Does anybody know which length is gonna change in Floyd-Warshall? If we do, this is the elbow, and this is the path, right? Does anybody know which one's gonna change? Which edge are we gonna, yeah, 4 to 3. So this is gonna be a 3. Yeah, 4 to 3, yeah. And basically, we keep doing that until we all get all the shortest path between each vertex, right? So essentially, just by going through the elbow is a lot faster. And literally, let me just show you the code. It's so clean. Like, literally, Dijkstra is disgusting, but, like, Floyd-Warshall is clean as heck. Okay, hold up. Whoops, we gotta go to the sketchy one. Okay, REPL. Okay, so literally this is all you need for Floyd-Warshall. It's literally 3 for loops, one line of code, and you're done. You literally found all the shortest path. It's really, really easy. So that's why we would use Floyd-Warshall instead of Dijkstra's, because even though it's slower, it's a lot easier to implement, okay? And now that we have all the distances between things, now we get to do the harder part, which is, how do we convert A, B, C, D, E to... On USACO, are you allowed to... I mean, yeah, I see no reason why not. Yeah, you for sure could. Like, I don't see any reason why not. Like, literally, you could even, like, search up algorithm. Like, you can't use other people's implementations, but you could, like, search up, like... Yeah, you could search up how to do, like, simple things. Like, how to write your own exponential function. As long as you do it yourself, it's fine. Okay. So, basically, we want to change this to, like, a good streak, right? So, does anybody have an idea of, like... how, like, what's an example of a streak? Well, okay, I'll just give it to you, but, like, basically the best thing to change this to is, like, this, right? So what is the cost of changing this to this? Just, like, what do we have to sum in order to change A, B, C, D, E into A, A, C, C, C? Come on, which things are changing? Yeah, so we need to convert B to A, we need to convert D to C, we gotta convert E to C, right? And basically that's just gonna be A of BA, right? Because, like, according to this thing, like, this is A, wait, where does it say? Yeah, it takes AIJ to change from one thing to another thing, right? So ABA plus ADC plus AEC. Okay, so now the problem with this is, like, how do we decide what this sequence should be, right? Like, how do we decide this one is suddenly the best one? So, okay, okay, so let's say we're trying to find the similarity between two string sequences. What strategy would we use? Does anybody know what strategy string, like, finding how similar two strings are? What strategy they use for that? Like, it's unrelated to this problem, but, like, if you know what they use for that other one, you could probably apply it to this one. So does anybody know what they use for string similarity? Like, minimum number of changes to change one string to another. Anybody? Okay, well, the answer is DP, okay? But, well, yeah, that's what I was talking about, but yeah, they use DP, right? And basically, what's a good DP for this, right? Does anybody have an idea for what our DP could be? So keep in mind that n goes to 10 to the 5, right? So we can't do something like n by n matrix of DPs, right? So that's not going to work. So we probably will have an n somewhere, and we'll probably have a k somewhere. So what could our DP be if it involves both like the length of the string and like the number of letters? Does anybody have an idea? What could we make our DP? Okay, well, DP is like recursion, right? So how could we split up this boy using recursion? Like, how would we want to build up our answer? Yeah, exactly, yeah. So whenever you're faced with like a string problem and a DP problem that you like, it seems like a DP problem, you always make it so it's like DPI, where like this first thing represents the first I letters, right? Okay, and basically, so let's just say, okay, but then what should the second thing be? So let's just think about it, right? So basically we have this, let's say we find out that, not quite, yeah, last letter is actually correct. Okay, so this is going to be the last button. Okay, so now basically, let's say that it costs like 2 days in order to change AB into like AA, right? So essentially DP of like 2A is gonna be equal to 2. Okay, and let's just say, okay, so then what could our recurrence be? Like in a DP you need to do a recurrence, right? So in terms of DPI, like what is DPIK in terms of other things? Hold up. Well, okay, let's just say that we want to make okay, so let's say we want to extend this to C, right? So how do we use dp2a equals 2? Or let's just say dp2, dp2a is equal to 2. So basically the idea is here, right? We know that this streak already ends with a, right? We already know it ends with a, so we can either add this guy to an existing streak, or, well, okay, so what would adding this to an existing streak do? Like, what would the cost of adding this to the existing streak ending in a cost, right? So, like, let's say, so we had to convert this to a, right, to add it to the streak ending in a, right? So what's our total cost for dp of like 3 and a? Anybody have an idea? So we essentially had to like convert this to an a, and we had to convert the first two to an a. Yeah, exactly. So our dp3a is going to be dp2a plus ij, ca, right? Okay, now but this is not the only case, right? We don't necessarily have to add it to an existing streak. What else could we do? Add a non-existent streak. Well, not added as it is, right? Because if you add it as it is, then you would have to keep track of how long your streak is, right? Okay, so Preston, for example, wait, don't worry, okay, hold up. Yeah, because basically the problem with Preston's approach is if you just add it as it is, then you lose all information about how long your streak is, right? Because your streak might be like one thing long, and you just don't know about it, and then how do you know if your streak is valid? But Victoria's thing is right? You can add a new streak, right? Okay, so what is the minimum length of a streak? It's just going to be k, right? K is the minimum size of the streak. So essentially what we got to do is we got to convert the last k guys to a, right? So essentially we basically add the cost of last k to a, and then what do we have to add? Like what dp, or well, there's the other option. So then what else do we have to convert to anything? Like what else? Like what is the total cost of this? What is the best cost of converting the last k to a? Any idea? This one's kind of complicated, but does anybody know? Okay, yeah, so basically the idea is, right, like, after you convert this to a streak, right, it doesn't matter what the heck this is, right? So essentially, for this, we just take the min of all, like, dp of 1 of anything, right? dp1 anything. Okay, so this right here is your recurrence, and Literally, this only takes, what's the complexity of this if we have to loop through all dpij? Any ideas? How big is a matrix? Any idea? N times 26, exactly. It's not even that bad. N times 26 is nothing. So let me just show you the code real quick, and then we could be done for today. So essentially, we start off with setting up all our dpijs to like infinity, right? We just say that, oh, it's not possible to get to anything at the very beginning, and then we do our recursion, right? So this right here, which case does this correspond to? This is basically saying the cost of converting the current letter to j, and plus the cost of converting the previous things to a streak ending in j. So which case does this represent? Okay, there's two cases, right? There's converting the last one to join a previous streak, or converting the last k to create a new streak. So does anybody, which case is this? Ideas? Okay, I'll just walk you through it. This is the case where you're converting the last one to j, and you're adding it to a previous streak ending in j. And then we just take the min of, literally this could be anything, right? Like your previous things could be whatever the heck they want, and then we're converting the remaining stuff to a completely new streak. It doesn't matter. So essentially, this right here calculates the cost of that streak, and we use prefix sums for that, but it's pretty complicated. So I made a video on this, so if you guys want to check it out, then go ahead. But other than that, we are done for today. Thank you guys for coming. If you guys want specific USACO just a problem, just let me know. But I know you guys had to go to class now, so feel free to drop. See you guys. Yes, I do have a video on this, so if you want to check it out. This is so sad. Okay. All right, see ya.